Good afternoon, students. It's Mrs. Cinti here, and we're going to start a new chapter today on multiplication. We're going to be multiplying whole numbers and decimals. This is the beginning of chapter 2. So let's go ahead and get started. This section is just about looking for patterns and knowing what to do with the multiple zeros that you may be multiplying by each other, as well as moving the decimal if you're multiplying something by 10 or 100, some kind of power of 10. So let's go ahead and begin by just discussing this first part. So let's talk about moving the decimal and adding zeros. And we'll work through some examples of this. Okay, so the first part of these notes is just looking for some patterns. So we all know that 1 times 2 is equal to 2. Okay, this means how many, if I have 2 groups of 1, how many groups do I have? Okay, so what if I say 10 times 2? That means that I'm wondering how many 2 groups of 10 are. And you know already that 2 groups of 10 is 20. The way, however, that I'd like you to look at this for this section is this number right here, looking at the non-zero integer. So here's the 2 and here's the 1. And this is the kind of pattern I'm asking you to kind of re-look at these problems with. 2 times 1 is 2, and then there happens to be an extra 0. And so we put that extra 0 on here. Okay, so we're taking a step back from what 2 groups of 10 looks like and rather looking at what these numbers are doing in this pattern. So let's look at another example. Let's say that it's 100 times 2. And now with this new perspective, let's think about how we want to look at it. So 1 times 2 is 2. And then there are 2 zeros here. And so we put the 2 zeros there. And we already know that 2 groups of 100 is 200. Now let's think about when we don't have as straightforward of a combination. Let's say instead that we're dealing with 15 times 2. Okay? 15 times 2 we know is 30. What if we add some zeros in here though? Let's add a different problem. 15, instead it's a 150 times 2. Okay. The way I want you to think about it, the way that we're thinking about it in this section, is we are saying, what is 15 times 2? We already know that that's 30, but then look, there's that 0 there, so we're going to add the 0 to the end. Okay, so this is the new 0 that we're adding to the end. This allows us to get really creative with how we are looking at these problems. So let's try 1500, so 1,500 times 20. Getting a little trickier here. Now, again, let's look at the new way we're being asked to look at this. 15 times 2 is 30. And then how many zeros are there on these factors? There are 3 zeros on the factors, so we will add 3 zeros. 1, 2, 3 zeros because of the 1, 2, 3 zeros on these factors. So our product is 30,000. Let's try another example. Let's go ahead and try, let's try 15000. Ooh, 15,000 times 2,000. Okay, this is going to be maybe a bigger number, right? Well, look at this. I'm just trying to get crazy with the colors. 15 times 2, we already know, is 30. Okay, and then we have 1, 2, 3, 4, 5, 6 zeros. So we have to add another 6 zeros on here. And so we have 30 million. Okay, but by breaking it down and looking for these patterns, that will help us to better solve these problems. Now, what if there already is a decimal in the problem? So let's start with kind of this second scenario that we're looking at today. Let's say that we have, what about decimals? Let's put that in our notes. And then, the question mark, sorry. And then we'll say, we are going to move the decimal one place to the right for each 0 in the factor. So let's go ahead and look at a couple of examples of this. So let's say that we have let's say 10 times 0.03. We already know that 1 times 0.03 is 0.03. By having this extra 10 in here, okay, this extra 0 on the 10, we're looking at these notes that we just made. Move the decimal one place to the right for each 0 on the factors. Not these beginning zeros, right? But rather these ending zeros. So here we have 1 0 here, so that means that we're going to move the decimal one place to the right. So instead, our number is the decimal is going to be here. Instead of having 3 hundredths, instead we have 3 tenths. Okay, let's look at, let's say that we multiply it by 100. Here's 0.03 again. This is our original problem, or this is a new problem. We have 2 zeros here, which means that we have to move the decimal 2 places here. 1, 2 here, and so that moves the decimal to the right side of the 3, which turns the 3 hundredths into 3 in the ones place. What if we have something like this? Let's just try a couple of other ideas here. Let's say we have 100 times 0.005, 5 thousandths, 2 zeros here, so we move it 2 places here, so we have 0.5. Always put that 0 in front of the decimal just to keep kind of the visual sanity of all of us. Let's try another one. Let's say 1,000 times 4.3. How many zeros are there in 1,000? There are 1, 2, 3, so that means we're going to move the decimal 3 places over. 1, we've run out of spaces, but don't forget there are zeros implied here all the way. So 1, 2, 3 times, 1, 2, 3 times means that we have 4.30, but we move the decimal over 1, 2, 3 places, so that means that we have 4,300. Okay, let's look at another similar example. I'm going to erase this. Let's say that we have 10,000 times 0.0435. 1, 2, 3, 4. 1, 2, 3, 4. So we have the new decimals here. We rewrite it. We get rid of those leading zeros, and we have 435. You're welcome to rewrite it at first with all the zeros in there, 435. This is where the new decimal is, but just report your number without the excess zeros. Okay. Okay, and then of course, who am I to not challenge you a little bit? I'd like you to think about a problem with a little bit of algebra in there. Okay. Let's say that we have something like x times 20 is equal to 60. We're given this problem, and the question is, what is x? Now, in your heads, I'm sure you can figure this out. How many groups of 20 would make 60? And I know you know 3 groups of 20. 3 times 20 is going to give you 60. However, if we didn't know that right away, you could think to yourself, 3 times 2, what times 2 is going to give me 6? Okay, so take away the zeros in your mind. What times, so the way I want you to think about it in this case is, what times 2 is equal to 6? And the answer is 3 times 2 is equal to 6. There's a 0 here, and that's why this other 0 is here. Let's look at another example. Let's say that I have something like y times 4 is equal to 1,200. Now, what I'm asking you to do is to isolate the integers without those zeros on there, okay? So y times 4 is equal to 12. So what times 4 is equal to 12? Already you know that 3 times 4 is equal to 12. Now there are these zeros to contend with, okay? These two zeros must have come from this number here because it's definitely not on that 4. So now you know it's 300 times 4 is equal to 1,200, okay? Because those zeros brought those zeros in, okay? Let's look at another problem, and then we'll, another similar problem. Let's say that we have something like, I'm trying to find an example in your book. Let's say 1,000 times m is equal to 8.77. Okay, so here we have a decimal, and you learned that you are supposed to move the decimal one place to the right for each zero. So that means for each of these zeros, the decimal was moved to the right that way. So that means that whatever this number is, okay, had 877 in it. So 877 in it. It starts here, but that means that we're going to move the decimal over 1, 2, 3 places. 1, 2, 3 places. So that meant that the decimal was here. We moved it 1, 2, 3 places. Because there's nothing here, the zeros pop back in, and that means that the original problem was 1,000 times 0.00877. And then we just make sure that this is indeed equal to 8.7, so we want to test ourselves real quick just to always make sure we have the right answer. 1, 2, 3, we would have moved it 1, 2, 3 places, which would have turned us into the 8.7. So we can check ourselves and make sure we're correct. Okay, good luck on the homework. I'll be here for any questions when you're ready. Have a lovely afternoon.